Hello and welcome to lesson 4.5. In lesson 4.5, we're going to work on graphing our parabolas or our quadratic equations and functions that we've been working with. More specifically, we're going to dive into using something called vertex form. Okay, now we've talked about what a vertex is and we know how to find a vertex. That's extremely useful. Okay, now graphing these things, I'm going to ask that you graph them using a table of values. Okay, and I want you to have about 5 points on your table. Now, here's what's going to be really interesting about when you make your table. Because you know how to find the vertex, you already have a leg up. What you're going to want to do is have the middle point be your vertex. And then I just need you to graph 2 more points on each side. Okay. Now, what's fun about this is I can be mean and give you quadratic functions written in this way, like 2x squared plus 3x plus 5, and say, okay, find the vertex, then pick points on each side of it. Okay. Or I can be really nice to you, and I can do something called rewriting these things into what's called vertex form. Okay. And that's going to look this way. You're going to have x minus some number, or the opposite of some number squared, plus another number. And if I ever have it written in this way, what I'm doing is giving you the vertex. The vertex is always going to be the opposite of h for the x value and k. Okay. So for instance, if I were to give you the function um, f of x is equal to parentheses x minus 3 squared plus 1, I know the vertex without doing any hard labor or any work. The vertex of this thing, I already have that middle point that I'll need. The vertex is the point 3, 1. So I know that I have the point 3, 1, and I would just need to do a point 2 points above and 2 points below. So I'd plug in a 2 and a 1, I'd plug in a 4 and a 5, and I'd get more points. Okay, so here's the important key thing. Because the formula has a minus sign right there, it's always opposite the sign of what this is. So you see minus 3, and notice I have a positive 3. And notice in the formula, it's a plus sign with the k or with the y value. So you take whatever sign is there, positive 1 with the y value. That's extremely important. Okay, now, here's the next important part that I'm going to be really polite. I'm going to give you vertex form, but you already have the skill to get into vertex form. All you would need to do is something we've already covered. Complete the square. Use that completing the square skill to write these things in vertex form. But instead of moving this number to the other side, you just leave it there and you add your perfect c to it. And then you write this part as a square and you have this leftover number. Okay. But let's actually jump right into trying to graph these. And like I said, I'll be really, really nice and go ahead and give them in vertex form since this is for a very fast summer course. So let's try to graph maybe the one I just gave you. X minus 3 in parentheses squared plus 1. And like I mentioned, we're going to want to do this using a table of values, or XY table, or input-output. In the middle function, or the middle point, we want the vertex, which I said is opposite of this, same as that. So 3, 1, we have the vertex. Let's go ahead and graph that. So 3 in the x direction, 1, 2, 3, 1 in the y direction, and there is our vertex. Now, we're going to want to pick 2 numbers above and 2 numbers below. So I'm going to want to pick a 2 and a 1. And I'm also going to want to try a 4 and a 5 to help me fill out the shape of this graph. Now, I don't care whether you do this in your head, on scratch paper, in a calculator, but all I'm going to do is plug these numbers in and kind of just it's plug and chug from here. So put a 1 in. 1 minus 3 is -2. -2 squared is 4. 4 plus 1 is 5. Put a 2 in there. Okay. Plug a 2 in. 2 minus 3 is -1. -1 squared is 1. 1 plus 1 is 2. Let's throw a 4 in there. 4 minus 3 is 1. 1 squared is 1. 1 plus 1 is 2. Put a 5 in there. 5 minus 2 is, 5 minus 3 is 2. 2 squared is 4. 4 plus 1 is 5. Look at this interesting symmetry we get on each side of the vertex. But I should be able now to happily graph this. Let's go graph all these points. 1, 5. So 1, 1, 2, 3, 4, 5. I think I counted correctly. I'm very bad at counting graph tick marks correctly. 2, 2. 1, 2, 1, 2. The point 4, 2. So 1, 2, 3, 4, 1, 2. And finally, the point 5, 5, which I believe is right there. And if you look at what we have a very beautiful, wonderful, magical parabola with a vertex at the point 3, 1. That was not hard to graph. Let's maybe do one more example of these things. Okay? And I can try to get more annoying with it, but I mean, it's not going to be really any more difficult than that. So let's give you one like this. X plus 2 squared plus 3. Okay. So once again, I'm going to want to make a table to do this. Input, output, or XY table. I'm going to need the vertex. Now, what is the vertex? Let's see how many people get it correct here. How many people fall prey to my trap that I just set you? That's right. The vertex is -2, +3. Because remember, it's always the opposite sign of what's in here with the x being squared. And then it's the same sign here. So -2. This is +2. So our vertex is at -2. +3 stays +3. So I need two numbers on each side. So going lower, I'll go to -3 and -4. Going higher, I'll go to -1 and 0. And those are the numbers that I'll need to plug in and get the outputs to get my parabola. So if I put a -4 in there, -4 plus 2 would be -2. -2 squared is 4. 4 plus 3 is 7. Like I said, use a calculator, use scratch work. I don't care. You're just plugging in numbers. You are good at this now. It doesn't take long. Put a -3 in there. That's -1. When you add 2 to it, squared is 1. 1 plus 3 is 4. Put a -1 in there. -1 plus 2 is 1. 1 squared is 1. 1 plus 3 is 4. Put a 0 in there. You have 2. 2 squared is 4. 4 plus 3 is 7. So, see if we can graph this. -2 up 1, 2, 3. Let's graph the other points. -4, 2, 3, 4 up 7. 1, 2, 3, 4, 5, 6, 7. -3 up 4. -1 up 4. And 0, 7. And I have a beautiful parabola. Okay, I cannot draw a good parabola to save my life. Once you draw the lines through all these dots, you have a beautiful parabola, which I'm very bad at doing. Okay, I still missed the last dot, but you get the idea. Okay, so that's actually really simple in this form. I will say the hardest skill probably is being able to get it in this form. I'm being nice because this is a summer class without much time. But if I wanted to, let me do one quick example. If I wanted to practice getting things in this form, let's say I have 6x plus, oh, I don't know, 8. Nope, 9. I could say, oh, actually, better yet, let's just do this. 6x minus 2. And say, okay, let's see if we can write this in vertex form. All it is completing the square. All you're going to do is say, okay, I need this perfect piece right here. I'm just going to scooch this -2 over. Now, because I'm going to add it right here, I'm also going to subtract the same number here. So I'm not changing the value. I'm adding and subtracting the same number. So what is the perfect number? Remember, it's just half of this squared. So it'd be like adding 9. I add 9, I subtract 9. I have not changed any of the values. And so what you get is this is a perfect square of x plus 3. My plus sign's messed up. X plus 3 squared. And -2, -9, that's -11. And I've written it in vertex form just that easily. Okay. Instead of doing this on the other side of the operation like we did back a few lessons ago, we can just hang on to it out here and it becomes our -11. Okay. Now, I'm not making you do that on your homework or test. I'm going to be really polite and already give it to you in vertex form. But just if you're curious, that's how you do it, is by completing the square. Now, let's take this vertex form and let's take it a step further into another type of shape, which is going to be really interesting. It's going to look very similar. Okay, and what we're talking about here is we're going to say, hey, let's dive into a little bit more than just parabolas. What if I wanted to do something with circles? We put this piece of the course here because it matches nicely with graphing in vertex form. So the special form that we're going to use for circles is very similar to this vertex form. It's going to look like this. X minus h squared. Hey, that's like kind of the completed square part. But plus y minus k squared equals r squared. So what this is this is the radius. And these pieces are the x and y point of the center of your circle. Okay? The center of your circle. Notice once again that it is the opposite. And it is the opposite for both the x and y coordinate of this center. Notice that this is squared, so if we get a number like 16, the radius isn't 16, the radius is 4, because 16 is 4 squared. Okay, so I think maybe we're ready to try graphing one or two of these. So let's say I give you a function like this. F of x equals x minus 3 squared plus y minus 5 squared. Oh, is this going to fit on here? Equals 16. Okay, now what's really great about this is we've given you the center of the circle because it's the opposite sides of these. Just like we've given you the vertex in the vertex formula, the center of this circle is the point 3, 5. Opposite side, opposite. So let's find 3, 5 and go ahead and mark it. 1, 2, 3, 2, 3, 4, 5. There's the center of our circle. Now the radius here, 16, is the same thing as 4 squared. So the radius is 4. So what that means is if you go 4 from our center, 1, 2, 3, 4, and let's say you go 4 in all the directions, up, down, left, right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If I could draw a perfect circle, it would go through all these points. I am horrible at drawing perfect circles. That's not horrible. Okay, that is horrible. But there's my circle. Okay. On your homework, you're going to have a tool to help you draw circles. The bottom half's not too bad. But that's all you need to do. It's really easy. If it's in this form, you get the center, you figure out the radius, mark your center, count the radius up, down, left, right, and draw your circle. Okay. One more example, maybe? One last example. So let's give you a function of a circle. Let's say it is x plus 2 squared plus y minus 1 squared is equal to 9. Let's see how many people are going to mess up what the center is and how many people remember and going to get it right. What is the center point here? Right, is -2, +1, because remember, this is the opposite of the x coordinate, this is the opposite of the y coordinate. So +2 here, so -2. -1 here, so +1. Now what's the radius? That is the same thing as 3 squared, so 3 is the radius. Okay, so mark the center, -2, 1, and the radius is 3, so 3 in all directions, up, down, left, right. 1, 2, 3. Boom. 1, 2, 3. 1, 2, 3. And finally 1, 2, 3. And then attempt to draw a beautiful circle. Hey, that was pretty good. That's a pretty good circle for me. Yay! Maybe I should end there. Okay, I'm joking. That is all I have for you. Okay, so all this last lesson in chapter 4 is can you graph parabolas using vertex formula? And can you graph circles using the center and the radius? Not super duper difficult, but just a good introduction for things if you go into trig or some pre-calculus and things like that to be good